All right, well, welcome aboard. So here's me, just a little bit about me. I'm on my 10th airplane, which is my third T-18, which is this gorgeous, wonderful machine. I'm in love with it. I'm up here at Twin Oaks Air Park near PDX, Portland, Oregon, and come visit. I'll give you a ride in the plane. Very quick shout outs, and then we're getting started. So flights above, specifically their Facebook pages are great. And they're kind enough to let me promote this webinar on there. So I'm just scratch my back, scratch your back. So nice of them to let me do that. Then these other Facebook pages that I'm part of that are good discussion groups. Jump in if any of those apply to you. So here's what I did. I had, I don't know, 6 or 8 things in mind for this webinar. And I thought, okay, well, that's not going to fill a webinar. So let me farm it out to the chat group at Twin Oaks, my fellow instructors. There's almost 30 of us, as well as to those CFI discussion groups that you just saw. And oh my God, look what came back. That's page 2, page 3, page 4, page 5. Whoa, okay, this is not gonna fit into one webinar. Oh my God. So we will do the best we can, starting with a very consistently controversial subject: grounding the aircraft for fueling. Why do we need it, and how should we do it? Oh my goodness. So why, for example, from a Yahoo Answers group, someone said, why do you have to ground the aircraft before fueling? Something about static electricity, etc. So one person, Crocodile Jim, 8 years ago, answered, I used to think this problem was exaggerated until I met a man who had seen a Handley Page Halifax, one of those airplanes right there, destroyed by a static spark in World War II. The fuel hose had been carried up a ladder to the overwing tank fillers, and refueling started without connecting an earth or a ground lead. A spark jumped the gap between the nozzle and the fuel tank. The fuel vapor in the tank and the fuel from the hose ignited. And even though the crew somehow miraculously escaped uninjured, the aircraft was a total loss. And just in case you still need more proof, what happens is the main way, to the best of my understanding, how aircraft become charged with respect to the ground or with respect to the fuel nozzle. Some of it is from just the flow of fuel itself. You'll hear that when I get to one of my videos. But in flight, it can pick up a lot of static, and that's why higher performance airplanes, just about all the Bonanzas and others, have static wicks hanging off the rear ends of their ailerons and elevators to bleed off the static. Otherwise, the static discharges mess with the radio reception. So, but the ultimate example of static discharge destroying an aircraft is this.
Finally, the landing lines are dropped. These scenes were filmed by Pathé News cameraman William Deek, and you're about to see the pictures he got when the ship exploded. Those aboard leaping for life from a flaming inferno. The actual crash of the Hindenburg. An airship destroyed in less than half a minute.
Okay, well, you know what happened after that, and that was caused by static discharge. Some long static discharge happened because of the static electricity that had built up from its long flight, and boom. In other words, it's a real thing. So hopefully that answers the question of why we need to pay attention to grounding. All right, so let me show you a quick video I did on my airplane to see, like, well, okay, what's ground? If I'm going to taxi up and get fuel, where should I clip the alligator clip? Let's find out. Hey there, Philip Mandel, flight instructor up here at Twin Oaks Air Park near Hillsboro, Oregon. Thanks for joining me today. When we fuel an aircraft, what's the first thing we do once we pull up to the fuel pump or the fuel truck shows up? Ground the airframe, right? We want to be sure that there's no chance of a spark when we're adding fuel into the fuel tank. So why might that happen? Well, fuel is a pretty good insulator. Just imagine you're walking across the carpet and dragging your feet, and then you touch a doorknob. That spark is what can be caused by fuel flowing through anything, because fuel is not a very good conductor. Therefore, if you were to just grab your fuel hose, come over here and start pumping, you're building up static electricity by the flow of fuel going through this. It's basically a rubber hose, big thick rubber hose. And that can build up static electricity such that the fuel going into the fuel tank can be picking up static electricity even after it leaves the nozzle. I'm a retired electrical engineer. Maybe I'm talking too much engineering here. The real point is that there may be a voltage difference, a difference of potential between the fuel nozzle and your filler neck on your fuel tank. Why is that bad? Well, how does an aircraft engine work? It needs fuel, air, oxygen, and a spark. Well, there's fuel in there, specifically fuel vapor, which is what works in the engine. Fuel vapor is explosive. That's why engines work, internal combustion engines. Well, here's a little internal combustion engine, because there's fuel vapor. How do I know? Take the fuel cap off, take a few whiffs. If you can smell fuel, that's fuel vapor. This invisible stuff around us is air, including oxygen. And all I gotta do is add a spark, and there's a non-zero chance that you just created an explosion. I recommend against that. So what we want to do is whatever we can to ensure that the fuel nozzle and the filler neck of the fuel tank are at the same electrical potential, so to minimize the chance of a spark. So you want to ground the airplane before you grab the fuel nozzle and start pumping fuel. Here I have a handy dandy little ohm meter. So now we're going to measure ohms or resistance or continuity between something on the airplane and the filler neck of the fuel tank. So what some people do is use the exhaust stack. They take that big alligator clip on the end of the ground wire and grab the end of the exhaust stack like this. You might want to come down even if you have to go sideways. There we go. And so here's my alligator clip. Here's the exhaust stack. I'm going to clip that to that. And just to prove that that's really connected and that this thing, of course, is conductive metal, we'll just measure the continuity between the pipe and the pipe. And I got a little resistance here because it's because of just the normal corrosion. But basically, it's very low ohms. It's essentially a continuous electrical conductor. So that's proving that that connection is good. And this, of course, is metal. We know that anyway. So let's stand up. What we really want to know is that electrically connected to the filler neck of the fuel cap, of the fuel tank? Anybody want to guess? Watch this. Here I am on the fuel tank. No change in reading. There is no electrical connection at all between the exhaust stack and the fuel tank. No electrical connection to the airframe. Let's come down here if we could. This is Eric, my videographer for the day. Thank you, Eric. We're going to touch the tie-down ring, which is connected to the airframe. Tie-down ring screws into the spar. No connection. In other words, the exhaust stack is useless when it comes to grounding for fueling. And let's find out, in fact, if the tie-down ring would work. So let me go back down here. I'll grab the tie-down ring with my alligator clip if it'll hold. I need a bigger alligator clip. And I'll come up here to the fuel tank. Guess what? 0 ohms. So there's a solid airframe connection, whereas the exhaust stack is not. Why is that? It's metal, the engine's metal, etc., etc. Number of reasons. First of all, if you put a brand new stack using brand new bolts and everything is brand new, maybe there's continuity. Then you run the engine for a while with, I don't know, 1500 degree exhaust gas blowing out, and everything starts to get corroded because you got hot gas heating everything up, and the air is always around with oxygen. Things begin, corrosion is the wrong word, oxidize. So any of those surfaces that are vibrating against each other, and then oxygen gets in, they start to oxidize. All of a sudden there's insulation between the different metal parts that maybe used to have continuity. So for this exhaust pipe, there's a little expansion joint in here so that can wiggle around freely while the engine moves around on its mount. There's a place where the continuity can be lost, where the exhaust stacks plug into the bottoms of the cylinders. First of all, there's a gasket there that it's not necessarily conductive all the way through. Well, what about the bolts? Well, those bolts are sitting there at hundreds of degrees, and they get corroded. And look, there's no continuity. This is the proof. By the way, this is a Lycoming 0360, 180 horsepower engine, a standard aircraft engine that you find on, of course, many certified airplanes. So yeah. Okay, well, I hope that's clear, at least on that particular airplane. My airplane exhaust stack, no-go when it comes to grounding. All right, well, what the heck? Let's just go look at a Mooney. How about that? We'll find something different. Okay. We'll find something real interesting. Here is a Mooney. I think it's a C model Mooney, if that matters to anyone, but it really doesn't matter. And yeah, so we're going to check and see if this exhaust pipe can be used to ground for fueling. And while I was trying to get this set up, I noticed my alligator clip. When I tried to clip it to this, I wasn't really getting continuity. So, you know, if the metal, if the exhaust stack is that well oxidized, then even putting a clip on it won't get you a ground, even if this is electrically connected to the airframe, because you can't get enough of a bite to get through the oxidation. Oxidation is really hard to get through. You need to grind it or steel wool it or sand it. You need to really get at it. You can't just do it with a clip. Maybe if you really work at it, you can get through it if you had a real strong alligator clip. But anyway, here's the meter. And if I touch the two leads together, see it goes down to near 0 ohms. So I'm going to come up here and touch the exhaust. I'm having trouble seeing what I'm doing and doing it at the same time. So here's, let me get the leads organized. Okay, so I touch the exhaust and touch the exhaust right next to each other. If I have conductivity, it would come off of the 1, which is infinity, because it's all the way on the left. If I touch the two leads together right there, I get conductivity, right? But if I just touch the exhaust pipe to itself, if I just touch both leads to the exhaust pipe, even do a little scraping to try to get through the oxidation, I still don't get any conductivity. Let's think about that. if we can't even get a probe or an alligator clip to bite through the oxidation, how could we possibly use this as a ground for the airframe? I hope that makes sense. So hope you can see that tie down ring over there. So that's going to be airframe, and that would be a better ground for your fuel tank, which is up here on the top of the wing. All right, hope that makes sense. Thank you. All right, well, isn't that interesting that you can't even connect to the pipe? Even if the pipe was connected to the airframe, you can't get to the pipe if there's enough oxidation. You really don't want to be scraping on that. That can create stress risers, and that's where the thing can crack. Or if you're not the aircraft owner might come and not be happy that you're scratching the heck out of their exhaust pipe. So I hope that speaks to you. So interestingly, so I went and looked for some videos online to can I get anyone to agree with me? And I found plenty of them that are doing what, in my opinion, is maybe not the best way. For example, here was a video where this young lady is showing how to fuel the airplane, how to run the computer pump and all that stuff. And here she goes grounding to the exhaust stack. Well, I'm not sure that's the best thing to do. Even a very well-known guy, Jason Schapper, he's a very strong instructor, does a lot of videos. And he's half right. In this video of his, he shows it going to the tie-down ring, but on the way from the fuel computer where he's dragging the wire, he said, you could either go to the exhaust stack or the tie-down ring. I'm gonna go to the tie-down ring because it's closer. Okay, well, stick with the tie-down ring would be my suggestion. Well, now here's an issue. Darn it, what if the tie-down ring is painted or rusty? That's not an actual tie-down ring on an airplane, but it serves the point. That's a problem because you're not getting through that. And so, gosh, we have a problem here. So general aviation news, talk about tips to ground an aircraft while refueling. And some say connected to the exhaust stack. This may be okay. It may not be okay, but some owners did not like their chrome stacks all scratched up. We have the corrosion issue. We have the other issue where some of them just aren't connected and so on. Others say to bond to the landing gear or front strut. Maybe. I talked to my mechanic who's an IA and asked him about that. And he said, you know, there's a lot of grease in those bearings. And when you grab the head of a bolt, let's say on your landing gear, that bolt has a washer and there's a bunch of grease and the bolt goes through a hole, there's grease in there. Grease is an insulator. So unless there's metal to metal contact, you have infinite ohms. You have no conductivity whatsoever. That's not going to save you. This last sentence is the most worrisome and most meaningful in this article. The problem is that a bonding location should be identified on all new aircraft. I would say on all aircraft, but none of the manufacturers are willing to do that. So tips to protect your plane from bad fuel, also from General Aviation News. This is a really good article. I just want you to look up online. It talks about all the issues with respect to fuel, including the fuel farm itself, the big tank that you're getting fuel from, like that. And it says, what is wrong with fuel? And there's so many places for things to go wrong, which is why we, every step of the way, need to be as careful as we possibly can. So what should we do? I'm sorry, the best answer I could give you is do the best you can. For example, on a Cessna, a lot of times there's this step where you can jump on that and then jump on the wing strut, other step, get yourself all the way up there. This is kind of a maybe. Those airplanes, these are old 150s. People have been up and down these things a million times. So that black, paint, whatever that stuff is that you step on here, a lot of that has just been, wiped away by people stepping up and down a million times. So there's some bare metal there. The problem is there's only there might be a little tiny lip of bare metal that you can touch, and you got an alligator clip that's this big, trying to grab a little tiny edge of something that doesn't want to stay. So that's not great, but it's a start. What about this one that's on, I'm sorry. So I just talked a moment ago about the using a landing gear or nose gear bolt. That's also a maybe because of all the grease that may be between everything and causing high resistance. A definite no is the step up here on the wing because it's just strapped around a painted strut. There's no electrical connection here at all, so forget this one. So gosh, what should we do? Well, we're sort of saved. Really what you want, don't think so much of that it has to be at ground potential. So for example, if there's a fuel truck and your aircraft, they don't have to be at literal earth ground potential. They just have to be the same as each other or very close to it. So that sort of happens that happens automatically when the fuel nozzle touches the filler neck. It's unavoidable. This is now an electrical contact with that, and therefore, if there was a static charge, it's now gone. The thing is, you don't want that discharge to happen while you have those fumes there, while the cap is off. So what you could do is take your ground strap. I don't know where you're going to strap it on the airplane, but at least find some bare metal somewhere and just at least touch it. Then connect it anywhere you want. And when you get up to the filler neck, if you can, touch the nozzle to the metal of the near the filler neck. If the fuel cap is in the way, you may have to just take it off and then approach it from the side. So that just pretend there's going to be a spark and try to keep that spark out of the hole, if that makes sense. Once that's done, now you can really, if you just touch the nozzle to the filler neck and keep it in fairly, it doesn't have to be perfect. You're keeping everything at the same potential. Things to be careful of always, of course, is don't torque or stress. In other words, the nozzle's in there in the hole, and if you go, if you lean on it, you're going to deform the fuel tank and the wing, and that's not good. And also try not to scrape back and forth because you don't want to create metal filings that are going to drop into the fuel and eventually clog a fuel screen or something like that. So here's an example of do the best you can with an airplane. I don't see any good place to ground to. I really don't want to use the exhaust pipe, shiny as it is, for the reasons we discussed. The tie-down ring is kind of rusty. So what I would do is just bring this up to anything that's metal and bare, not painted and not rusty, and just touch this to it, and that will discharge your static from flying and such. And then just do the best you can. Just grab anything with it. In this case, I'll grab the tie-down ring, even though it's rusty. Hopefully it's better than nothing, but the fact that you touched it to something metal like a screw head that's attached to the airframe, that's your discharge. And the amount of static charged just by fueling should be minimal, at least compared to the amount of charge picked up during flight. So what I would do is, even between tanks, once I finish one tank, I would take this off and go touch it to the screw head again and then put it back on, just because of the rust. Make sure I get that discharge before fueling the second tank or third or fourth, etc. So in order to get an explosion, they'd have to be a different potential. You'd have to have the gas cap open. You'd have to get close enough and have the spark happen where all those fumes are. So a lot of things have to go right to get an explosion. So let's make sure that the go right doesn't happen. I hope that makes sense. All right, next topic. Crankcase breather and battery box vent. These often get ignored, and I am in fact guilty of not adequately instructing my students in this, and I'm going to start now. So I got. How about the oil breather tube, crankcase breather, and the battery vent. A little bit hard to see. Here I'm in a 150, a little bit upside down. The metal one is the crankcase breather that lets relieves pressure in the crankcase and just go. So this is famous for dripping. Look, there's some drippage right there. Right here. Where's my finger? There I am. Right there. So that's normal. And then the battery box has its own vent. You don't want to touch that because that could be acid. Okay, so the crankcase breather is important to pre-flight, and the battery box vent, if you can find it. They may be in two completely separate places if the battery is aft somewhere in the airplane, for example. And here's an arrow showing you the crankcase breather. I don't have time to explain why that's important. I just want you to look it up, please. Just briefly, I'll say that the crankcase of the engine is not supposed to be pressurized. If that breather tube gets plugged or iced up, that's bad because the engine gets hot, everything's expanding in there because of heat, air, and water vapor, and that can start to put pressure on the seals on the crankcase, and you can start getting blown seals. So it's rare that it happens. It's probably only going to happen in very, very cold weather where the condensation gets in there and starts to turn into ice, and it blocks itself. But so please find that on all your pre-flights and do what you can to take a look at it and pre-flight it. Next topic. Oh gosh, putting the keys in the ignition switch and then going to pre-flight. That scares me more than I can tell you. So let's check this out. Okay, so let's talk for a second about keys. What to do with the keys before you start your pre-flight. What some people do is put the keys in the ignition, and that's where they stay while they do the walk around. I'm going to argue against that. I do teach my students to put the key in the ignition, make sure it's the right key. In other words, does it move? Because you could put the baggage door key in there and think you're in control, but you're not. So make sure it's the right key, and then make sure that it's all the way off, and then pull them out. Put them anywhere else. Put them down there on the floor, here on the fuel selector, here on the glare shield, unless it's a 90-degree summer day, then you won't be able to touch them. Anywhere but in the ignition slot. And the reason is that this can actually accidentally be turned on. These mag switches, especially the older ones, get really, really soft. The clicks are real soft. Some of you may have flown older aircraft where you notice that it's hardly a positive click anymore, and you may actually have a magneto energized without knowing it. And then we're going to go around the front. Let's just pretend we're going towards the nose of the airplane. And you're out here and you start doing your stuff, and you're looking at the prop, and then you want to get to the alternator belt, but the prop's in the way, so you're going to move the prop. And if you move it as far enough to hit the impulse coupling, which is that click you hear when the prop starts turning, if you have a hot magneto, and if there's even just a little bit of fumes left in the cylinder, in one of the cylinders, that can cause that cylinder to fire while your hands are here moving the prop, and you think the prop is cold. And by the time that blade comes around and chops your hand off, you won't even know what happened until you're injured. So let's go ahead back inside. So I'm begging you not to leave the key in the ignition. In fact, don't even put it near the ignition until you're ready to start, after you're at the priming and master switch on and starting point. Don't put it on when you're starting. Don't put it in there when you're just starting your pre-start activities, because you may accidentally kick it over to one click. It might happen because your knee hits it. In my car, sometimes I get in and out of my car, my headlight switch is there, and sometimes my knee bumps it and the car beeps at me telling me, hey dummy, you just turn on the headlights. So it happens. So well, what's wrong with that? You're in here and you're doing your pre-start stuff, and what heck, so who cares if it's like that? Well, you might get interrupted. You might have to go out and say, oh, I forgot to pull the nose chocks, or I forgot to check this, or I forgot to check that, and this thing is sitting there hot. Bad. So please don't plug this in here except just to check that it's off before you pre-flight. Take it out, put them anywhere else. And then of course, the other things I do when teaching my initial pre-flight to students, make sure the throttle's all the way out, make sure the mixture's all the way out. Sometimes these end up in strange positions. So these should be fully aft, throttle out, mixture out, mags all the way off. And then take the key out and store it until it's time to start the engine. Okay, I hope that works for you. Let's go back over here and see what's next. The master switch. This confuses people and wastes battery life unnecessarily sometimes. A lot of people like to lower the flaps partially or fully as part of their pre-flight. And if you have electric flaps, like in this Cessna 172, you need battery power for that. Notice that the master switch on this Cessna and most Cessnas has two halves. There's this it's a rocker switch that you can turn on both sides or one side. So the right side, typically it's on the right, and if you can read the silk screen, it says BATT for battery. That energizes the electrical system. The ALT, the left side, all that does is provide power to the alternator field, which does no good unless the engine's spinning, because the alternator is not doing anything unless the engine's running. So turning on the whole master switch when all you want to do is lower the flaps or set radios or check the fuel gauges is wasting battery power. Make sure you only have the battery side on, and there's a good chance you'll have a light lit up or something like that telling you, wait a minute, we don't have an alternator. Well, that's because the engine's not running. So all you need is battery. In an airplane that's still got a mechanical turn coordinator, you're going to hear this noise. You may hear fan noises and things like that. That's fine. So then, of course, you'd come over here, lower the flaps as much as you want. I'm just going to leave them up because we're not actually pre-flighting. And, of course, you got your fuel gauges. They come alive with the power. And so that's the main point I want to make is if you only need battery power, just turn on the battery. Leave the alternator off in order to save power, energy in the battery. All right, I hope that makes sense. I would like to add to that something I just learned recently from one of my fellow instructors, Brian at Twin Oaks. He was helping check me out in our RV-12, and he made a very, very good point, because I'm just going down the checklist the way we normally do, and it says, you know, master switch on. I turn the master switch on, and I look for the next thing, and he says, wait a minute. What just happened? Like, what do you expect to happen when you turn the master switch on? And did that happen? That's an excellent point. Basically, anytime you flip any switch or turn any knob, you need to have in mind what do you expect to happen, and then verify that that's the case. So for that particular airplane, if you turn on the battery or the entire master switch, you should get noise from the turn coordinator. The fuel gauges should pop up. There was an EGT gauge there that lit up and things like that. It's like, did anything happen? And if you turn on the master switch and you don't get that turn coordinator noise, that should get your attention. Like, why isn't this thing winding up, for example? So I thought that was a great suggestion on his part. Brian, I appreciate that. All right, a little bit more on engine starting. All right, let's talk through the engine start checklist briefly in our 172 and just discuss a few little details. On this particular model year checklist, it's the first thing it wants you to do is turn the rotating beacon on. Of course, it may be a flashing beacon in your airplane. So if we can read the silk screen, we can find the right button. We're turning that on ahead of anything else, and the reason, of course, is that once we do get to the point of starting the engine, we at least have something visual outside that's hopefully going to catch people's attention and indicate to them that that engine is about to start. So we just want to make ourselves visible. And for the next item, mixture rich, that's pretty easy. Make sure it's all the way in, and there should be a small gap. Some people keep trying to push and push and push. The point of that gap is that it means that the mixture control is full rich at the carburetor prior to bottoming out here on the panel. If this actually hits the panel, you don't actually know that it's full rich literally at the carburetor. So a little bit of a gap there. And the same thing if your throttle full, you can have a little gap there. That way you know it's full at the carburetor. Otherwise it bottoms out here. You don't really know what's happening at the carburetor. Anyway, so the next item is throttle open 1/8 of an inch. And they mean that. They don't mean 1/8 of the travel. And here's where some students get a little frisky. 1/8 of an inch is very, very tiny. I mean, it's from here to, that's it. That's 1/8 of an inch, not 1/8 of the travel. Because if you start it like this, it's just going to run up real loud and real hard. And going back out, I'm going to edit that out. So they mean 1/8 of an inch, which is like maybe, like that's probably more than enough. When what you want is for it to be enough such that when the engine starts, it just jumps up to 1,000 RPM or 900 or something like that. You don't want to be 1/8 open. See that little tiny inch mark is just a little, quotation mark. It's like 1/8 with the little bitty symbol that means inch. And some people miss that and they think 1/8 open, which is like way in there. What's going to happen when you start the engine like that? It's going to be at 1,500–1,600 RPM, make all this noise, run the engine hard right off the bat when it's cold. When you want to start it more gently, it's going to blow air at whoever's behind you. So 1/8, and it's 1/8 of an inch, not 1/8 open. It's just that's it. All right. Carburetor heat is going to be cold for engine start. I usually take this opportunity before there's any noise, before we're spending money on fuel or hops time on the airplane, just to exercise it. It costs nothing to do this. Gently, bring it all the way out. Make sure it doesn't come all the way out like this. If it gets loose in the engine compartment, this thing's just going to disappear. You want to do it now, not later on after you've taxied and so on and you're all the way at the run-up area. Find out now if it's hooked up and if it feels normal. So I pull it out and I push it back in, and notice it'll hit the bottom, but then there'll be a little bit of gap. That's how you know that it's fully closed, because because there's a little bit of gap there. Next item, primer, way over here. So it says primer as needed. I'm going to suggest you try most of the time, try starting without any prime. Most students, we find, tend to over prime, and a lot of times these engines, especially the Lycomings and the Continentals in the 150s, or the Lycomings in the 152s, etc., they'll often start without any prime. Now, you may get to know a particular airplane or your airplane really well, and you know, hey, if I give it 2 shots, it'll kick right in. Okay. But just wanted to relay that I and my fellow instructors here at Twin Oaks, we find that people tend to over prime. So if your first flight of the day, and if you got chilly, physically chilly pre-flighting the airplane, okay, now it's, you know that the engine's cold too, you might try 1 or 2 shots. But if it doesn't start within 5 or 6 seconds of cranking, stop cranking, give it 1 more shot. Try it again. Chances are it's going to start right up if you, as long as you don't over prime, and never crank more than just 5 or 6 seconds at a time, because all you're doing is overheating the starter and draining the battery. There are several seconds between priming and starting. And you want those two items as close together as possible. If you're going to prime, you want to prime, and then very, very soon after that, start the engine, crank the starter. The reason for that is the primer is going to atomize fuel. It's spraying fuel into the cylinder, and that fuel is now going to get onto the cylinder walls and start to dissolve the oil. And you don't want to do that. You want the oil to be the oil, because it's there for lubrication. And as soon as you start to dissolve that oil, then when you first start cranking, you've got metal against metal until the engine has a chance to pump oil in. So I might suggest changing this order. Do something like clear, which means shouting clear and looking around to make sure it's clear. Make sure no one yells back at you, wait, 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 there's a dog near your propeller. Excuse me. And also, please, please, please look behind you, or if you're, if you need to open your door, and lean all the way out and look around and make sure it's clear. Please, before you start the engine. It's very, very difficult. If you're one behind an airplane and the pilot goes clear and it cranks it up right away, you never had a chance to get out of the way. So please tend to that. So minimize the time between priming and starting. But again, less prime is usually better in most cases. All right, so now we're cranked up. You want to have your hand on the throttle. You're going to be watching the oil pressure. Make sure that comes up. The book usually says within 30 seconds. It pretty much should be immediate that it at least starts to climb. And then you're going to adjust your throttle to, if you're really just starting and the engine's fairly cool, you can set it to 900 and then take your hand off it and look at it 30 seconds later and it'll be 1,000. Because as the engine warms up, the oil gets a little thinner and the engine just starts to increase its RPM without you doing anything. If you set it to 100, pretty soon it's going to be 1,100 or 1,200 unless you pay attention and keep pulling it back. Just something to know about that. So, okay, so I hope that's clear, and we're on to the next segment. To that, have I said anything that's going to cost you any money? Nothing that I've talked about so far is going to cost you a dime. So it's just paying attention, doing things in the right order, doing things maybe a little differently than you were in the past. Just wanted to throw that in there. More pre-flight. What's wrong with this picture? Someone wasn't paying attention, were they? Pitot tube cover still on the pitot tube, and they're at altitude. Like, why didn't they just turn around and land? Okay, someone needs to slow down, pay more attention to their pre-flight. More pre-flight. Well, these are the same tire. These are both the left tire on my Thorpe. And the lesson is, if you have wheel pants, look how little of the tire you can see. And especially if you're standing up, you're walking around the airplane, you're seeing it at an angle, you say, it looks like there's good tread. I would encourage you to get down there, look at the front and the back of the part you can see, roll the airplane, a quarter of a tire turn or half a tire turn, and look again, because there's a little flatter spot on one side than on the other. In training aircraft that hit the ground a lot, let's say, and sometimes not always straight, there could be a pretty good scrape with cord showing on part of the tire, but you can't see it because it's hiding behind the wheel pants. Back to fuel. So hopefully when you pull avgas, I'm just talking 100 low lead today. I don't know if anyone uses jet fuel or anything. All I know is avgas. So you're going to have your blue, water is going to drop to the bottom. Here's a typical setup with the with the strainer. I'm going to throw in a plug if you're a renter and you're renting, FBO's airplanes. Well, I don't know about your experience. Once in a while, the strainer isn't there. It walked away with the last person that had flown the plane by mistake, or ended up in a different airplane, something like that. And sometimes they just get old, they just get dirty. You can't see well what's in there. And for 15 or 20 bucks, consider getting your own. That way it's yours. You take it from plane to plane. You know it's clean. It's not gonna, yeah, you get the idea. So please consider that. So now I'm asking you to spend some money, but it's tiny. All right, and so now this is real interesting. This guy made a video regarding checking the fuel. So I'm going to show you that. All right.
To use the petcock sampler and drain off a sample of the fuel. The reason we do that is to make sure that there aren't any contaminants. They could come from leaving the aircraft overnight. Maybe there's water, maybe the fuel truck, or maybe even the tank in which the fuel is stored could have contaminated your fuel, and that's not good news. So here's me, and I'm taking a sample of fuel. It's actually from a jerry can, and it's motor fuel. It's normal petrol, not aviation fuel. The difference being this isn't as highly controlled. It's also straw in colour rather than the blue that you would see in aviation 100 low lead. So I'm having a quick smell. It smells of fuel. It looks like fuel. And I'm just checking to see if there's anything in there. It looks clear. But remember, specific gravity of water is 1. Avgas is less at 0.72. So here's some water going in. Now can you see straight away they split? It's really quick. And here it is in slow motion. In goes the water. It bubbles up. And a lot of people think that if there's water in the fuel, it might take half an hour or so to get to the bottom of the tank. But look how quickly that water falls to the bottom of that fuel sample. The fuel's on the top, the water's on the bottom. And here we are again in real time. In it goes, and done. I mean, that's a couple of seconds, isn't it? Now, what about if you draw a sample and you're not sure? Maybe it's all water. Ooh, well, here's one method of testing it. Will it? Ah, it looks like it's water. Now, of course, I'm joking. This isn't really what you'd do. If you went to the airport and tried to set your fuel sample on fire at Heathrow, I reckon Special Branch would be onto you pretty quickly. So probably not the way to do it. Here we go, testing off another sample, and of course, oh my gosh, that one's fuel. Now there is actually something you can do if you're not sure. First of all, have a smell of the fuel. Does it smell like fuel? If it doesn't, that's a good hint. Have a look at it carefully. Is it blue? Or is it the right colour for what you're expecting? If not, then you need to do something. And what I suggest you do is put some water in there. You could, to be crude, spit in it actually. And if it falls to the bottom as a globule, it's water. If not, you're okay. It's fuel. Well, thanks for listening. See you next time.
Yeah, so that's someone raised an interesting point on when I remember when I got those suggestions from other instructors. You can tell when it's all fuel, and you can tell when it's fuel with some water. It's harder to tell when it's all water. Yeah, it's clear, but you know, you hold it up to a blue sky, you hold it up to the blue color of the airplane. You just, how can it be water? I mean, so I always take a sniff. Be careful, you know, don't just stick it in your nose. Do it the way you learned in high school chemistry class. Hold it and just kind of waft it at, and get used to the smell of avgas, of the type of avgas you use. So if it's water or worse, well, not worse, as bad, kerosene or jet fuel, no go in a piston airplane. Come on. Oh man, the mag check. Oh shoot, I really wanted to do that. So let's talk about that real quick. Your Magneto Switch. So you can go, you're on both because you just taxied, and then you run it up, you can go one and both, and then 2 clicks and then both, or vice versa. The question is, what if you make a mistake on the second check? In other words, you're at both, you go 1 click, watch the RPM, go back to both. Hopefully you're still watching, see the RPM come back up. You go 2 clicks, watch the RPM drop, and then you start to bring it back, and you feel like it's 1 click. You're not sure if it was 1 or 2, but you're onto the next checklist item, and you're not sure if you just did 1 or you don't know if you're on the left mag only or both. That's bad. This costs nothing. Just do it in a different order. It costs nothing. Standardize on 2 clicks first, Go back to both, watch the RPM come back up, watch the RPM come back up, watch it. You'd be surprised how many people don't. They're looking at the mag switch. Watch the RPM come back up. Go one click, RPM goes down. Stay with your eyes on the darn tachometer, please. Then if you feel one click or you hear it, or even if you glance away and look at it, that one click will get you back on boat. Why do it any other way? That's my question. Okay, great. Well, you know what? I've got 50 hours at least into this webinar. Fortunately, I have stuff already prepared for when we do part B, but I have an enormous amount of effort into this. If you think I've deserved a cup of coffee, I'd appreciate it. buymeacoffee.com/PhilM, PHILM. Totally up to you. I'd be very grateful. Happy Halloween. Don't text and fly. Okay, like that. And any questions or comments, again, there's my email address. I'm up here in Oregon, and so if you're up in the hood, definitely get in touch. Let's meet for coffee or flying, and I'll show you my airplane or take you for a ride. Anyway, phmand@gmail.com. I'd love to hear from you. Thanks so much for attending, and wait for part B. So again, appreciate you being here. We're 1 minute before the hour, so I look forward to hearing from you by email. Thanks again.